Building on your understanding of inheritance and polymorphism, it's time to take the next step, designing a well-structured program that minimizes complexity. The secret lies in mastering polymorphic design. Let's dive in. Imagine you're creating an app to manage different media types like books, movies, and music. Without a clear structure, your code could quickly become tangled. Polymorphic design offers a solution, enabling you to keep your code organized and logical. It allows each media type to share common functionality while still maintaining its unique characteristics. Let's create a basic class structure to witness polymorphic design in action. Here's the media class, the foundation for all media types. It captures the common attributes all media types share, like title and creator. The media class includes the parameterized constructor to initialize its attributes and a play method that offers a basic action suitable for any media type. This serves as your foundation for creating more specialized media types. Next, let's examine how we can extend the media class to create specific media types, such as books, movies, and music. First up is the book class, which inherits from media and introduces an additional attribute, page count, an integer representing the number of pages. The play method is then overridden to simulate reading a book, demonstrating how polymorphism enables you to tailor behavior to fit the specific needs of each media type. Next in line is the movie class, which also inherits from the media class and adds a unique attribute, duration in minutes. The play method is overridden to simulate watching a movie, giving you details about its length and illustrating how polymorphism allows each media type to offer a tailored experience. And finally, here's the music class, which inherits from the media class and introduces a new attribute, genre. The play method is overridden to simulate listening to music with a focus on the genre. Once again, polymorphism shines by allowing you to customize behavior for each specific media type, ensuring each one delivers a unique experience. With all your media types now set up, this structure serves as a clear example of hierarchical inheritance in action. The superclass, media, is inherited by multiple subclasses, book, movie, and music, each adding its own unique attributes and behaviors. Now let's focus on how polymorphic design can simplify your program structure, especially when methods return objects. You can define a media library class with an add media method that accepts and returns a media object. Thanks to polymorphism, this method can handle objects from any subclass of media, whether it's a book, movie, or music, and return the object regardless of its specific type. Let's add one more method named playMedia to the media library class. This method is responsible for playing a media item. It leverages polymorphism to call the appropriate play method based on the specific type of media object. The media library class provides two key advantages. First, it promotes the separation of concerns by clearly dividing the responsibilities of adding media to the library and playing it, which enhances code readability and maintainability. Second, it offers flexibility. By keeping these concerns separate, you can modify how media is played without impacting how it's added to the library, and vice versa. Let's find out how this all comes together using the main method. In the main method, create 3 objects, one for a book, one for a movie, and one for music. Then, create an object of the media library class. Next, use the add media method on the media library object to add the book, movie, and music items to the library. Since the add media method returns a media object, be sure to store the returned value in a variable of the media type. Finally, call the playMedia method to play each media item added to the library using the media objects returned by the add media method. This method automatically calls the applicable play method in the background based on the specific type of media object. When you run the program, 3 media objects, a book, a movie, and a music item, are created. Although these objects are instances of their specific classes, they are treated as media types thanks to polymorphism. Because the add media method is called 3 times, once for each media object, the method prints a message confirming that each media item has been successfully added to the library, as reflected in the first 3 lines of the output. Then, the play media method is called for each media item, triggering the play method specific to the class of the media object. The last 3 lines of the output illustrate the process. For instance, when the added book is passed as an argument, play media calls the play method from the book class, resulting in the output, Reading The Great Gatsby by F. Scott Fitzgerald with 180 pages. And just like that, you've learned how to use polymorphic design to create a logical and maintainable program. By building a media class and extending it with subclasses like book, movie, and music, you leveraged polymorphism to keep your code adaptable and scalable. The add media method handles different media types, returning them as common media type, which simplifies interactions while maintaining flexibility. This approach is key to building efficient and manageable software. The program also shows how polymorphism allows the play media method to behave differently depending on the object type, demonstrating the power and versatility of polymorphism in object-oriented programming.